So, hello everyone again. This is the 7th lecture, part 1 of electromagnetic induction. I am Sameer Lavankar. So, let's begin our discussions. So, just a little bit course outline as we are starting with a new lecture today. So, we started with introduction part. The definition of electromagnetic induction is being talked in this lesson 1, followed by the experiments of Faraday and Henry. There were 3 experiments to be precise. Experiment number 1, experiment number 2, experiment number 3. Experiment 1 involved a coil C1 with a bar magnet. Let me denote the bar magnet by M. Then the experiment 2 involved coil C1 and coil C2, and experiment 3 again involved coil C1 and coil C2, but this time there was a tapping key K involved. Tapping key K involved. The process was similar. If the C1 is held stationary, then M magnet is moving either towards or away. If magnet M is stationary, then coil C1 is moving either towards or away. If coil C2 is stationary, coil C1 is either moving towards or away. If coil C1 is stationary, then coil C2 is moving towards or away, and similarly the case is in this also. Then lesson number 3, that is magnetic flux, value of phi b was being calculated, that is dot vector product of B and A, followed by Faraday's law of induction, that was epsilon, that is EMF produced, which is equal to minus n d phi b by dt, that is change in magnetic flux per unit time multiplied with the number of turns with a negative sign. Then followed by Lenz's law in conservation of energy, in which why the negative sign is coming, why the energy needs to be conserved, how is the energy changing from one form to another form is being dealt in this lesson number 5, followed by motional electromotive force, that is only and only the change in magnetic field B is not responsible for an EMF induced, either the change in velocity or the change in the shape of any conductor can also be responsible for the change in EMF, change in current, and then hence EMF is produced. Not change in current, current is induced and EMF is produced. Followed by inductance. So, inductance was a direct concept involving all the lessons we dealt in electromagnetic induction. Inductance is of two types, one is mutual, one is self, and for lastly we are talking about AC generators in the last lecture. First I will do a little recap of AC generators, then applications, and then we will deal with some problems regarding AC generators. So, now a quick recap of AC generators. This was the typical diagram of AC generators here. We already know anything, only and only these first two formulas written towards your right hand side were being used for finding out the EMF reduced due to a generator. There was a coil which was rotating in the magnetic field B with a change in direction, let me use the paper here. So, if the magnetic fields are like this, if the magnetic fields are directed like this, then if this is the coil's area, this is the effective area, then the effective area keeps on changing. Consider this to be planar. So, if this area is changing like this, and hence A dash, that is A cos theta is changing, and because of A dash cos theta being changed, the magnetic flux is changed. If the magnetic flux is changed, the time rate of change, because it is changing with time only, if it is changing with time, then d phi b by dt is not 0, and hence there is EMF produced. So, now so this concept is already known to us, that phi b is b dot a, which is B A cos omega t. Yes, but this time what we did was we used theta is equal to omega t. Then finally, we got the epsilon value produced is epsilon is equal to n b omega sin omega t. The complete concept of when it is maximum, when it is minimum, this whole concept was being talked in the last lecture very clearly, very in detail. Y at theta is equal to 90 degree is a maximum, y at theta is equal to 270, that is a maximum. It is a maximum, it is an extremum, but it is maximum or minimum. It can be a +1 or it can be -1 depending on the value of sin theta or sin omega t. So, it can be, but the mod value is always maximum when it is at theta is equal to 90 degree or theta is equal to 270 degree. Already discussed this complete figure here towards the down. So, now let us move on to the application of AC generators. So, what are the applications of AC generators? So, please look over carefully. So, in commercial generators as in which all the generators are used for commercial purposes, large offices or big sites or for mass production of electricity. So, those are things are commercial generators. So, in commercial generators the mechanical energy, please recap it that the AC generators convert mechanical energy into electrical energy. How is mechanical energy supplied? Let us say for a very simple case, we hand roll and we change the loops area, we change the loops area, we rotate the shaft, or using gears, some mechanical gears are being shifted like this, if the gears are like this, and then there is a rotator shaft which gets involved in this. So, then also everything involved with our hands or our gears is mechanical energy, and hence we are providing some energy, and hence it is mechanical. So, what does a AC generator do? It converts mechanical energy into electrical energy. So, now in commercial generators the mechanical energy required for rotation of the armature, please make sure what is armature. Armature is only a coil here, it is a physics term used for telling us or depicting us about coil. So, in commercial generators it is also written here, just for a quick reference, it is also written here that the coil also called as armature. So, now in commercial generators the mechanical energy required for rotation of the armature is provided by water falling from a height. So, as you can see the water is falling, water is here, it is falling from a height, let us say this is the height we are talking about. So, water is falling from a height, for example from dam. So, this is a dam, this is a typical dam here, this is a typical dam, no need to memorize the things here, just for a quick reference, just to quickly explain the applications of AC generators, I use this figure here. So, as you can see there is a transmission tower, is just used to provide some EMF voltage, some electricity, some sort of electricity, so that the transformer should work. So, this energy is being used for working of transformer. Then as you can see this is a dam, this is a typical dam, the water goes inside from here, and due to the potential energy being converted into mechanical energy being supplied to this turbine here, due to this the turbine rotates, and hence in this and hence in the generator there is a change in the effective area. Because of change in effective area there is EMF produced. So, this was one of the example of hydroelectric generators. Next, alternatively water is heated to produce steam using coal or other sources. So, this is one of the typical example from large since very long years water is being heated and using coal or other different non-renewable sources. So, alternatively water is heated to produce steam using coal or other sources, and this steam at high pressure produces the rotation of the armature, and these are called as thermal generators. So, if I am not wrong, this is the figure here being told us about this. So, what happens is in this furnace, look at this is a furnace and then this is a steam here. So, because of the water being kept here, it is converted into steam due to high temperature. Then there is a steam flow into a turbine. Because of the high pressure, high force which the steam provides to the turbine, it is a rotating shaft again. So, the shaft rotates, if the shaft rotates there is the coil will rotate, and hence there will be change in the orientation of the coil, and hence there will be EMF produced. Why there will be EMF produced? Because there is change in magnetic flux with respect to time. So, as you can see, as the shaft is moving, then this is of no use for you now. This is nothing but the value of water which is being circulated. This water is being recycled again and again. So, this is of no use. Please just look over this issue that the steam is being converted, the steam goes into turbine, and then turbine's shaft is being moved, and hence in the generator EMF is produced, and hence current EMF is produced, and as in we get energy, we get electrical energy. So, this is the second concept, that is the application thermal generators. So, it has a application in hydroelectric generator, it has an application in thermal generators. Now, instead of coal, if a nuclear fuel is used, then we get nuclear power generators. Just in the place of coil, if we use any nuclear substance, then it is nuclear power generators. It is quite evident that the energy produced in nuclear power generators will be much higher than thermal generators. Now, modern day generators produce electric power as high as 500 megawatts. So, as you can see today, in an electric power generator can produce as high as 500 megawatts. Megawatts is the unit used to denote the power. So, power is denoted by in watts. 1 megawatt is equal to 10 to the power 6 watts. So, now modern day generators produce electric power as high as 500 megawatts. In most generators, the coils are held stationary, and it is the electromagnets which are rotated. So, a little different concept is being used here. So, let me explain to you using some of the things I have here. So, what was happening when we were talking about AC generators concept was ki let us say this is the area, this is the area of the coil we are talking about, and let us say these are the magnets being kept here. So, because of the magnets being kept here, the magnetic field will be like this, the magnetic field will be going in this direction. Now, what happens is in the typical generator which we are talking about, the magnets are being held constant, and the area, because it is connected to a rotator shaft, let us say the rotator shaft has the axle like this, it is connected to a rotor shaft, and then that rotor shaft is moving. Because of that rotor shaft being moved, the area, the coil is also moving. So, if the coil is also moving, there is a change in the area, there is a change in the actual A dash effective area. So, it keeps on changing, and hence the area B is being changed. Please make sure that the magnets are always intact, and it is like this only. Now, what does this last second point says ki in the generators what they do is, let us say the area is being kept intact, that effective area is always like this, there is no change in this. But what happens is, let us understand by using, this be the two bar magnets we are talking about, let this be the two electromagnets we are talking about. Bar magnets cannot sustain such high voltages. So, let us say these are two electromagnets. What is happening is, now they are changing the orientation of these bar magnets only. So, the bar magnets are being moved like this. So, this is only a simple change in the concepts. So, first of all, this was moving like this, but now the bar magnets are moving like this, this is kept intact. So, what happens is there a change in the formula? No, there is no change in the formula. What will just happen is, let us say the phi value was B dot A, which is equal to B multiplied by A multiplied by cos theta. In the previous concept, what we did was we defined flux as B multiplied by A cos theta, which is equal to B multiplied by effective area. What we will do now is that magnetic flux will be nothing but B cos theta multiplied by A, as in to make it analogous, it is nothing but effective magnetic field acting on that particular area. Only change is this, the value of B, as you can see that it is same only, just A cos theta is being used, B into A dash or B dash into A. So, this is a typical concept I just made to keep you understand, it is not written anywhere. There is no such concept as effective magnetic field. Just for a quick response that anything does not change, the concept does not change, the value of magnetic flux does not change. Only to explain this thing, I have explained to you this in this way. So, the concluding statement of this slide is that the frequency of rotation is 50 hertz in India. So, when we were talking about theta is equal to omega t na. So, here we already know what is omega. Omega is nothing but 2 multiplied by pi multiplied by f. So, the f used here is nothing but 50 hertz. In India, this f value is nothing but 50 hertz. So, this was the complete concept and application of AC generators. Now, we will go to a simple typical problem of AC generator. So, let me, after the applications, let me go to the problem, a simple problem regarding AC generators. So, as you can see, the formula is also already updated regarding AC generators here. So, these all are the formulas being used in the complete chapter of electromagnetic induction. So, let us look over the problem here. So, Kamla pedals a stationary bicycle. The pedals of the bicycle are attached to a 100-turn coil of area 0.1 meter square. So, please make sure what are the given things here. Capital N is given to you as 100, the area is given to you as 0.1 meter square, as it is given in meter square only. So, there is no requirement of changing it into something different. Let us say it was in centimeter square, then you have to convert it into meter square. Next, the coil rotates at half a revolution per second. Because the revolutions are given, it is not radians per second. So, it is quite evident that this is the frequency we are talking about. So, the frequency is nothing but 0.5 revolutions per second, or in terms of hertz we can say it as 0.5 hertz, and it is placed in a uniform magnetic field of 0.01 Tesla. So, capital B is also given to you as 0.01 Tesla, perpendicular to the axis of rotation of the coil. So, as it is perpendicular, that means the value of theta is 90 degree, and hence sin theta is equal to 1. So, the concept being used to find out the value of here sin theta will be 1. Moving on, what is the maximum voltage generated in the coil? So, a simple mathematical substitution into this formula is being used here. There is nothing difficult in this, only mathematical calculations are being involved. So, let us look over the solution here. So, given n is equal to 100, already told, A is given to you, B is given to you, and F is given to you. So, then using the below equation, what was the below equation? That is NB into omega. What was omega? Omega is nothing but 2 pi f. F is given to you. So, just a simple putting, n is 100, B is 0.01, area is 0.1 meter square, 2 is already known, pi is already known, and the frequency is already known. That is a typical putting of everything. We get epsilon naught, that is maximum voltage is 0.314 volts. Why it is called as maximum volt? Because of sin omega t, sin theta can only take the maximum value of +1 or -1. So, maximum value is nothing but NB into omega. Therefore, the maximum voltage is 0.314 volts. So, this was a typical problem. So, in this lecture we talked about a recap of the EC generators, followed by the applications of EC generators. So, there were typically two major applications. One was hydroelectric generators, one was thermal generators. If in place of coal there was nuclear fuel being used, then it is nuclear power generators. It is quite evident that the power or energy produced in nuclear power generators will be much higher than coal generators, that is thermal generators. And then finally, we concluded with that simple problem on AC generators. In the next lecture, I will be talking about the summary. So, for now your complete electromagnetic induction is completed. So, in the next lecture, we will talk about a little summary of everything, every concept involved, how it was linked to different things, and some problems dealing with every concept involving electromagnetic induction will be dealt. So, the course progress, everything is progressed only, just a little recap again. So, lesson 1 introduction is done, experiments of Faraday and Henry was done, magnetic flux phi b is done, Faraday's law of induction is done, Lenz's law and conservation of energy is done, motional electromotive force is done, inductance is done, and hence now your AC generators is also done. So, the course is completed. Thank you.